Welcome back to this live lesson series in gradient. We have done 2 lessons on coordinates and 1 lesson on gradients. Today we'll be looking at how do we find the gradient from 2 points. So if you recall from last lesson in the gradient series, we looked at how do we find the gradient when we've got the line. When we've got the line, we saw that if you've got 2 points on the line that we can make ourselves, the gradient is up divided by across. Okay, and we spent a long time looking at a few of those examples. If you can go back and watch that if you haven't already, it's going to make this lesson a lot easier. We saw that if you've got 2 points on a straight line, we can find the gradient by looking at up divided by across. Okay. And today we're going to be taking that into when we don't have a graph. So we were looking at when we have a graph, how do we do that? Today we'll be looking at when we do not have a graph. So here on example 1, we'll jump straight in. It says find the gradient of AB. When they say find the gradient of AB, what they mean is they want the line between A and B. So your first step is to draw a straight line that goes between A and B. We need to find the gradient of this line. Last lesson, this is what we did. We know that M equals up divided by across, and we have to draw a triangle. Well, if we look at our straight line, we need to draw a triangle that goes from A to B in the Y direction and from A to B in the X direction, and we need to check and be careful with our scale how many up it is and how many across it is. Well, how many up is this? Well, it's 1 square is 1 unit, so it is simply 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. So I can mark this one as 5, and it is 1, 2, 3, 4, 5, 6 across. Okay. So 5 up, 6 across. We can use our formula, which you need to remember. Up divided by across, it was, remember, 5 up, 6 across, so I can say this is 5 up divided by 6 across. So my gradient is 5 over 6. And we discussed last lesson that you can have a fractional gradient, and they're absolutely fine. And this is a positive gradient. So we looked at last lesson, what does a positive gradient mean? Well, a positive gradient means that is going up. When you look at this graph from left to right, the line would be going in an upward direction. So as a fraction, this basically says every time you go 6 across, you go 5 up. Every time you go 6 across, you go 5 up. And we can see that. 6 across, 5 up. Okay. So that is almost a recap of what happened last lesson. Here, example 2, we've been given a coordinate grid, and the question says A is the coordinate minus 3, 2. So that is just notation to say the point A has a coordinate of minus 3 on the X and 2 on the Y. And point B has a coordinate 4 on the X and minus 2 on the Y. And it says find M for AB. So here we have to just do a little bit extra work given our coordinate grid. The first thing that we should talk about is, what does M mean? Well, we know, don't we? Hopefully at this point. And if you haven't, please watch that series from last lesson, talking about the gradient and introducing it. M is what we refer to as the gradient. So this question is asking us to find the gradient of the 2 points A and B, the line that connects A and B. So we need to plot A and B on first. So if we plot A, it is minus 3, 2. So starting the origin, go to minus 3 on the X and 2 on the Y, we're going to get to this point here. And B is 4 minus 2. So we will go from the origin across 4 and down minus 2. That would take me to this point here. And if we label them A and B, because that's the labels we were given in the example, we can now connect these two with a straight line and do the same process that we learned last lesson. We're going to find out how many across it is and how many up it is to get from point A to point B. So again, check the scale. This is the same coordinate grid, so 1 square is 1 unit, which is fine. So this is going 1, 2, 3, 4 in the up, and 1, 2, 3, 4, 5, 6, 7 across. So 4 and 7. Now, we spoke about making sure you decide whether this is a positive or a negative gradient. Hopefully you're looking at this and saying, well, this is a negative gradient. Okay, this gradient is negative because it is going down. If I look at it from the left and go to the right, it is going in a downward direction. And I said about drawing a little man and thinking if he walks this way, what would happen? He would go down. So I know that my gradient m, remember m equals up divided by across, is going to be equal to, up is 4, across is 7, 4 over 7. However, it's a negative gradient, so it should be minus 4 over 7 because it is going down. Minus 4 over 7 would be the gradient. And what does that mean? That just means every time I go across 7, I have to go down 4 because it's negative. Every time I go across 7, I have to go down 4. Okay, and you can draw, we discussed, you can draw your triangles in that direction as well. It makes no difference. But that would be the gradient between the 2 points A and B. So today's lesson we'll be looking at how do we do this without having a grid. Okay, it's all very well and easy when you've got a grid, because you can simply just draw a triangle and find out how many up and how many across it is, given its scale, making sure it's positive or negative. But we want to know, how do we do this when you've just been given a sentence with 2 coordinates, 2 points, and how do we find the gradient without having to draw a grid? Because a really ineffective way would be to draw a grid. We could plot 1 and 4, which would be about there. We could plot 3 and 10, which maybe would be up there. We could draw a line and we could draw a gradient, but we want to avoid having to draw a graph if we don't need to. If we have a technique where we can find this gradient without actually drawing the graph accurately, because it's time consuming, then that would be brilliant. And there is something like that. So this box here, the Remember Me box, these boxes, if you ever see the Remember Me box, that is something that you might want to put on a revision card, because it's the key information for this topic that's going to make it possible for you to do. So I've just put at the top here, recall. This is from last lesson. We know that the gradient, which we refer to as m, is equal to up divided by across. Okay. So how are we going to use that to take 2 points without a grid and find a gradient? Okay. What we're going to do is focus on this graph here. If I've got point A with a coordinate of x1 and y1, so I haven't given a number there, I've just gave a generic x and y, because we know this one is x and this one is y. So if I had 2, 3, this would be x, this would be y. So instead of giving this a number value, all we're saying is for any value of x, for any value of x and for any value of y, and point B has got any value of x and any value of y. So how are we going to do that? Well, first of all, it's really important that I've called A x1 and x on B x2. Why do you think I've done that? Because they're both just x's, but I have to call this one x1 and this one x2 because they should be different points. Okay, so I'm just saying, look, you've got the first x coordinate, which we'll call x1, and we've got the second x coordinate, which we'll call x2. If I called them both just x, what am I implying? I would be implying they're the same, but we would like to know how this technique works with 2 different points. So the reason these have got a 1 and a 2 on them is simply to say, look, they're different. x1 and y1 is a different coordinate to x2 and y2. Okay, so what does this all boil down to? Well, we've got this gradient here, m equals, so if you have got 2 points, all you have to do, remember, up divided by across is the way we have been finding our gradient from a line. Well, what does up mean? Up is the y-axis, isn't it? If you go up and down, you'd be using the y-axis. And if you go across, you'd be using the x-axis. So what we say here is we take the second y coordinate, so we would take this one here, and I'm going to highlight now as you can see, we're going to take the second y coordinate, and we're going to minus the first y coordinate. So we're going to take y2 and we're going to take away y1. And we're going to divide that by, because we've seen that the gradient is up divided by across. Well, how many across would it be? Well, it would be the second x coordinate minus the first x coordinate. So the second x coordinate is up here, remember? Wrong colour. Up here. And the first y coordinate is what we're going to minus it. So that first x coordinate. Okay. Why is that? Why do we have to take the second y coordinate minus the first y coordinate? What is that doing? What is that actually finding for us? Well, if you look at our example we've just done above, and this will be so clear to you now, hopefully, let's only focus on the x. What is the x for point? What is the x for point A? The x for point A is minus 3. Okay? And what is the x? I'm just going to highlight that. Minus 3 is the x for A. What is the x for B? Well, the x on B would be 3. How did we get 6? Because we said it's 6 across. We got 6 from counting and working out the scale. But however, what is 6? 6 is the difference between this coordinate, the second coordinate for x, and the first coordinate of A for x. So what's the difference between 3 and minus 3? Hopefully you're thinking 6. So that formula that we just looked at is basically going to work out everything that we did on this graph without having to draw the graph. It's finding the difference, and this is what the gradient is. It's the difference, it's the change in y up, the change in y divided by the change in x across. And it's a lot easier to write up divided by across than change in y, change in x. So all we're doing is finding the difference between the two x values and the two y values, and we're just using our up divided by across. And that formula will just do it all for you without having to draw any graph. So that formula is really, really, really important. If you can remember that, these questions that we're about to do, these examples we're about to look at, will be really quite straightforward for you. And if you ever forget this formula, you can just resort back to drawing it, putting in 2 points and finding the gradient using the up divided by across method, where we just divide the triangle that we make. So, looks quite scary and overwhelming at first, but as soon as you start to see it in action, it's really quite straightforward. So, if we look at example 3, this is where we don't have a graph and we want to find the gradient. I've put at the top for you the formula, so you can just flick up and have a look at it. But what does it say? It says example 3. A line passes through the point 1, 4, okay, and 3, 10. Find its gradient. Well, we have been given 2 points. Whenever you get given 2 points and you've been asked to find the gradient, you should instantly think m equals y2 minus y1, which is the change in y divided by the change in x, which is x2 minus x1. Now, where do we get these numbers from? Where are we going to get y2, y1, x2, x1? Well, we are going to look at our coordinates. The first thing you're always going to do, once you've written the formula down, you're going to label your coordinates. We need an x1, a y1, an x2 and a y2, don't we? If we look at our formula, we need 2 y coordinates and 2 x coordinates. Well, we have that. So the first thing you're always going to do is just going to label the first coordinate x1, the first x value, and y1, the first y value. We're going to call the next coordinate, the second one they give you, you've probably guessed it, x2 and y2, because it's the second x coordinate and the second y coordinate. Now, the mistake that students make constantly is they do this. They know that they've got to label them, with numbers, they always call it x1, x2, and y1, y2. They always do that. It's wrong. Remember, a coordinate is x, y. So it's x1, the first x coordinate, y1, the first y coordinate, and x2, the second x coordinate they gave you, and y2, the second y coordinate they gave you. And then all this is now is a case of plugging these numbers, substituting these numbers, taking them and just sticking them into this formula. Again, we call that substitution. So we're going to take the second y coordinate, which we can see clearly after we've labelled is 10. So we're going to make that 10. So this is 10 minus, well, what is the first y coordinate? Well, clearly we can see is 4. We're going to minus the first coordinate for y, which is 4. Okay, and I'm going to put colours on here so you can map it up and see where everything's coming from. Over x2, which is going to be 3, because I can see I've labelled it 3 and it's the second x value, so 3, minus, because my formula says I'm minusing, I'm finding the difference, the first x coordinate, which is going to be 1. So I'm going to slap in 1 for that bit. So those numbers are illustrated for you there where we got them from. We've taken the second y coordinate, which was 10, and we've minused the first y coordinate, which is 4, because that's up, remember, divided by the second x coordinate minus the first x coordinate. And if we work this out, we're just going to get given the gradient, just like that. Okay, we're going to get given the gradient straight away. What is 10 take away 4? 6. What is 3 take away 1? 2. What is 6 divided by 2? 3. The gradient of the point 1, 4 and 3, 10 is 3. Our gradient is 3. What does that mean? The steepness of that line, remember, how steep the line is the gradient, is 3. And we know, hopefully, that if the gradient is 3, what that means is every time you go across 1, you go up 3. So across 1, up 3. That's what that line would look like. Across 1, up 3, if we were going to draw it. So knowing the formula, really important. Labelling the coordinates, really, really important. And then substituting them in carefully. So you might be thinking, where does this get difficult? Because that's quite straightforward. Where they try and make it hard for you is by giving you negative numbers. Because this formula has got a minus in it. And if you've got a minus and a minus, you can start to make mistakes there. So we'll look at examples that will have negative numbers in and how are we going to deal with those. So example 4 says points A with the coordinates 3, 2 and B with the coordinates 5, 13 are connected with a straight line. Find M for AB. So what's that saying? It's basically saying we've got point A, we've got point B, we want to draw them with a straight line, and you need to find the gradient. The first thing that should come into your head is M equals, the gradient equals y2 minus y1, the change in y, up, divided by x2 minus x1, the change in x, which we refer to as a cross in the last lesson. Then you label. And the labeling process is easy. That's the first coordinate they gave me. I'm going to call it x1, y1. That's the second coordinate they gave me. I'm going to call it x2, y2. Then I'm going to substitute in my values and just be careful. What is y2? 13. Minus y1. What is y1? 2. Divided by x2, which I can see my label is 5, minus x1, which is 3. Be really careful when you're putting those points in, okay? If you make a mistake there, you're going to get the answer wrong. So that is the step that you have to be careful with. Let's work it out. 13 take away 2 is 11. 5 take away 3 is 2. Does 2 go into 11? No. Are we allowed fractional gradients? Yes. So my gradient is 11 over 2. What does that mean? That means every time I go across 2, yeah, because up divided by across, that means every time I go across 2, I go up 11. So if I had a line, it'd be across 2, up 11. Okay, so what you could say is that's quite a steep line. And that's it, done. The gradient is 11 over 2. Every time you go across 2, you go up 11. Okay, so we've looked at just a nice positive one. We've looked at a fractional answer. Now we're going to look at when we've got negatives. This is when it could get tricky. Example 5. Find the gradient of the line passing through the points -8, 6, and 0, 2. Well, instantly, I've seen that they want the gradient and I've seen that they've given me 2 points. So I should be thinking, and you should be as well, m equals, if I've got 2 points, y2, the second y coordinate, minus y1, that gives me the up, over x2, the second x coordinate, minus x1, the first x coordinate. And that will give me the across. Then you label. What is my first x coordinate they gave me? Well, this was the first coordinate they gave me, so I'm going to call that x1, y1. This is the second coordinate they gave me, so obviously x2, y2. Simple as that. You take those, and now this is where we have to be careful. This is where we can slow down and really think. We need to put these in our formula. So the first thing I'm just going to do here is change those negatives to a blue, so you can see what's happening. This is going to be equal to y2. What is the second y coordinate? -2. So -2. Then we're minusing. Our formula says then we minus the the first y coordinate, which is going to be 6, over the second x coordinate, which is 0, minus the first x coordinate, which is -8. Now, this is the crucial part. Students will always miss the double negative there. I am doing the second x coordinate, which is 0, and I'm taking away, I'm taking away the first x coordinate, which is also a -8. So I end up here with 2 double negatives, a double negative. And that's important. If you miss and only put 1 negative there, you're going to get it wrong. If there are 2 negatives, put them in. Let's work this out. And negative numbers is always something people find difficult. You've really got to get to grips with it, because it can make questions like this, which are quite straightforward, very, very difficult if you get them wrong. It can always pose a challenge for you. What's happening on the top? I'm starting at -2. Always think of a number line. I'm starting at -2, and I'm taking away 6. If I take away, I'm going to go that way, left. Where would that get me? More negative. It's going to get me to -8. So I'd have -8 on top. And this is where we should be careful. I'm starting at 0, and I'm doing -8. Well, we know 2 negatives, if you take away a negative number, you're going to get a positive. So that is a plus. So what is 0 plus 8? It's going to be 8. Okay. So I'm just going to add that note for you. 2 negatives make a positive in that situation. What have we got here? I've got -8 divided by 8. Okay, what is -8 divided by 8? Well, what is 8 divided by 8? 1. And what's a minus divided by a positive? Well, a mixture makes a minus. 2 different signs, a minus and a plus, would always make a minus, so it's going to be -1. My gradient is -1. What does that mean? Because you always want to think, if I found the gradient, what does that actually mean? Well, it's negative, so it's going to be going down. If I've got a graph, it's going to be going down that way. And what does -1 mean? It means every time I go across 1, I go down 1, across 1, down 1. So my line is looking like that, across 1, down 1, across 1, down 1. So we could say that every time you go across 1, you go down, because it's negative, 1. And if you find that bit hard, where you have to visualize what's happening with the gradient. Like, what does the gradient mean? If you don't understand that, go and look at gradient 1, the first lesson I ever did on gradients, where it shows you what a gradient is and how they work. This is about, once you know that, how can you make the process quicker when you've got 2 points rather than drawing it. So again, if you're finding any of this last bit difficult, where you have to think about what does that mean as a gradient once you've found it, go and look at the first lesson. So that takes us nicely onto the final 2 questions, which will be the challenge questions, which will really stretch our understanding of this topic we've seen today. Example 6. The line passing through the point 3, 5 and K15. So straight away, we've got 2 number coordinates and then a letter and another coordinate. So that might be a problem. Has a gradient of 2. K is a positive integer. What does that mean? Usually students see that and they freak out and they don't know what's going on. A positive integer, that is the mathematical way to say a whole number. Okay, so what you want to do, put that on a revision card. If you don't know what integer means, it just means a whole number. So all this says is K, this coordinate, this number that we don't know, this K that we have no idea what it is, we've called it K because remember, in maths, if you don't know what something is, you call it any letter, an unknown. So this K just means there's some number, but they're being nice and saying, look, it's positive and it's an integer, which means it's a whole number. So this number K will be some positive number, like 1, 2, 3, 4, 5, all the way up to infinity. It could be anything that is positive and a whole number. They've asked us to find K. So what's my thought process here? They've actually given us the gradient. Every other example that we've seen, we've had to find the gradient. We've been given it here. But the key to this is, what have I got? The gradient is the context of this question, and I've been given 2 coordinates. What do we know? Oh, m equals y2 minus y1 over x2 minus x1. We know that if you've got 2 coordinates and you want the gradient, all you've got to do is find the difference in the y's divided by the difference in the x. So we're going to do that, and we're going to fill in what we know. So we're going to look at this formula and look at the question and say, right, what do I actually know about any of this? M. Do we know what m is? Yes. We know that the gradient, which we know is called m, is 2. So we know that m is 2, right? So we know that. What is x1, y1, x2, y2? Well, let's label. Let's label it. That's the first x coordinate they gave us. That's the first y coordinate they gave us. This is the second x coordinate, so x2. This is the second y coordinate, so y2. Let's start to fill in what we've got then. Using our coordinates and using our equation, what have we got? Well, we just said we know what m is. M is 2. So I'm going to replace m with 2. What's y2? y2 is 15, so I'm going to bang 15 in. Minus y1. What is y1? 5. Yeah, the first y coordinate. Minus 5. Over x2. What's x2? Dunno. But I know it's called k, so I'm going to call that k. That is the key here. I don't know what x2 is, but I know it's called k, so I'm just going to bang in k. Minus, what's x1? 3, yeah? x1 is 3. The first x coordinate they gave us is 3. So what I'm just going to do actually, I'm going to change everything apart from the k to blue, so you can see clearly that I have just put the k in. Okay, and maybe we'll change that back to the orange so it shows where the gradients come from. The gradient m was given, is 2, so I put 2. These y's and these x's here were just in the question, like all of the other examples. The only thing that I haven't got a clue about is k, so I've just put in k. What have we got here? Well, hopefully you're looking at that thinking, that's an equation. I can solve an equation. We need to solve this equation to find out what the hell is k. Yeah, we want to know what k is. So let's get going on that. How do we solve equations? Well, we do the same to both sides. We lay it out, we show what we're doing, and we do everything in a logical order. The first thing we need to do to solve this equation, I usually put lines down the side. If you don't, if you lay it out differently, that's fine. But the first problem we want our answer to say k equals some whole number. We know that. We were told that k is some whole number. Right now, k is at the bottom of a fraction. And we do not like fractions when we're trying to solve an equation, especially if what we need as the answer is at the bottom as the denominator. So the first thing we're going to do is take this bottom and we're going to times it up, because we do the opposite. What's the opposite of divide by k minus 3? The opposite of divide by k minus 3 is to times by k minus 3. So I'm going to times both sides by the denominator k minus 3. And I'm going to put it in a bracket. Why am I putting it in a bracket? Because there is more than one thing in that bracket, in the denominator. So if there's more than one term, stick it in a bracket. So I'm going to call that k minus 3 on this side. Why am I showing this on the side? This is basically showing to the person marking my work, I know that I need to do it to both sides, and this is what I'm doing. What do we get there? We are going to multiply this by 2. So everything in that bracket we're going to multiply by 2. What's 2 times k? 2k. Yeah, that's 2k. What is 2 times minus 3? Minus 6. Now, this is the problem that students have. If I've multiplied all of this side by k, all we're doing is cancelling that off, so all we're left with is the top. And what is the top? Well, what is 15 minus 5? 10. So look what we've created. We've just made a horrible looking equation into something that I'm pretty sure most people can solve. Yeah, that's the thing that you learn first when solving an equation, ones that look like this. So the thing that we had to do is get rid of k off the bottom of this fraction, multiply it up, expand it out, and we're left with just 10 on that side, because 15 minus 5 is 10. How do we solve this? Well, we want k on its own. Anything attached to the k we're going to leave till last, so we're going to leave the 2 till last. And we're going to get rid of this minus 6. How do you get rid of minus 6? You do the opposite. You add 6. Adding 6 to both sides will give me 2k equals 16. Okay, 2k equals 16. Divide both sides by 2 is the last step, because I only want 1k. And 2k, remember, means 2 times k. And the opposite of times by 2 is to divide by 2. So if 2k is 16, that missing coordinate up here, k is 8, does it fit what we were told? We were told k is a positive integer. Is our answer positive? Yes, 8 is positive. Is our answer a whole number, an integer? Yes, it is. So we're done. So we've used that formula we've learned today. We put in everything that we possibly knew, which gave us an equation with a missing k that we don't know, that we had to solve, and then we're done. So 3 steps to that. So now the final example is going to be a very similar question, but obviously I'm going to put a negative and I'm going to put a fraction in there. So we're going to see, this is probably one of the hardest versions of this question you could get. We're going to see what happens. We've got a line that passes through the point -2, 5, and 2n. So straight away, I'm thinking, don't know what n is, but I want to know. It has a gradient of -0.5. So what's that? They're telling me what? What's gradient mean? M. They've told me straight away that m is -0.5. Okay, so that's what that says. N is a positive integer. What does that mean? Well, we've discussed that a second ago. That basically means that n is a whole positive number. Positive integer just means a whole number. And surprise, surprise, they want to find n. Like I said, we saw that there was a n in the coordinate and they want us to find it. Well, straight away, how does my brain work? How do I know what I should do here? What's the context of this question? Gradient. What have they given us? 2 points. What do we know? Oh, to find the gradient of 2 points, m equals y2 minus y1 over x2 minus x1. So if you don't remember that formula, these questions are very difficult. If you know the formula, they're fine. So what you want to do is write it on a revision card. Definitely. Let's fill in what we know then. What do we know? Make it a bit smaller. I'm going to run out of room. What do we know? Do we know what m is? Yeah. They told us the gradient is minus half, so we know what m is. Okay? We know that m is minus a half, so I'm just going to highlight m to show that we know what it is. Let's start filling things in. We know that m is minus a half. Okay, so we've got minus a half equals y2. Well, let's label these coordinates. The first coordinate they gave us was that one, so that's x1, y1. This was the second coordinate they gave us, so hopefully at this point you're happy and comfortable with labeling this x2 and y2. Then we're just going to take what we know up here and we're going to bang it straight into this formula down here. What is y2? y2 is n. So, we don't know what that is, so I'm just going to write n. No idea what n is, but I know that the second y coordinate is actually n at this point, so I'm just going to call it n. Minus the first y coordinate. Well, the first y coordinate is 5, so I'm just going to bang in the 5 there. Divided by the second x coordinate, which is 2, minus the first y coordinate. Now be x coordinate, very careful. What does that say? Minus 2. And what we spoke about earlier was, if you've got minus and a minus, you have to make sure you write it down. So the formula says we're going to take away the first x coordinate. What is the first x coordinate? Well, it is minus 2, remember that? Minus 2. So I end up with a minus minus, which is no problem, but if I don't put it there, it is a problem. If I only put one negative there, we've got an issue. Can we tidy anything up? Well, let's have a look. The bottom can. What's that? What does the bottom become? Minus minus 2. 2 minus minus 2 would be plus. That becomes a plus, remember? Two negatives become a positive. So I end up with minus a half, still on that side, minus half, and you might want to call it minus 0.5. That's absolutely fine. Yeah, if you want to call it minus 0.5 because you don't like fractions, you can. So let's just do that, see what happens. Instead of minus half, minus 0.5 is the same thing, looks a bit nicer. Equals n minus the 5 on top, and we just worked out that the bottom was 2 minus minus 2. 2 add 2 is 4. So we've got an equation that we need to solve. I'm just going to bring this up here. If I have this equation, 0.5 minus 0.5 equals n minus 5 over 4, what do we want? Remember, the goal of this, we're trying to find n. That's our goal. We're trying to get what n is. What's my first problem? Well, there's a fraction. Yeah, we don't like that fraction. I'm trying to get to n, and right now n is trapped as the numerator, the top of this fraction. So if I could get rid of this 4, it would think of it as unlocking this. How would I get rid of that 4? Do the opposite. What's the opposite of divide by 4? Times by 4. Remember, you've got to do it to both sides to keep it equal. What is minus a half times 4? Well, how are you going to think about that? The best way you can think about that, if you're doing it in your head, is what is half of 4? 2. And what's a negative and a positive times together? A mixture makes a minus, so minus 2 is the answer to that. If I times this side by 4, I've got rid of that 4 there, which is the whole goal of me doing it. So I'm just left with the bit on top, n minus 5. And hopefully you can see we're almost there, we're at the home straight now. We want to get n on its own. What's stopping it from saying n equals this 5? How do I get rid of a minus 5? I plus 5. Plussing 5 to both sides would give me, well, negative numbers. What's minus 2 add 5? If you're at minus 2 and you add 5, it gets you to where? 3. And if I've got rid of that negative 5, remember, what is negative 5 add 5? Gone. That's why it goes. So that's gone. I'm left with n. N is 3. So, sorted. They are some difficult questions. They're the type of thing, if you are in a higher GCSE class, that's the type of question that could come up in an exam. Be organised, label, sub it in. Just get comfortable with solving equations that have got fractions in them, basically. And if you can do that, you'll be fine. Okay, so what are our takeaway points from this lesson? Remembering this formula. If you have two coordinates, x1, y1, and x2, y2, you need to know that the gradient m is equal to y2 minus y1 over x2 minus x1. You also need to be very, very careful when picking your x1, y1, x2, y2 and putting them into the formula, substituting them into the formula. You have to be careful. As we've seen, if you've got two negatives here, you need to make sure that you've written two negatives and you know that that makes a positive. What else do we have to be careful with? Labeling. You have to label your coordinates, and it is easy. Just don't put x1, x2. That's wrong. Make sure, look, that's the first coordinate, so it's x1, y1. That's the second coordinate, so it's x2, y2. And that maps perfectly with our formula. Okay, so that will conclude this lesson. Where does this series go next? We'll be looking at the equation of a straight line and all of the fun things that come with that. It's a big topic. Hopefully you learned something, and I will see you in the next one.